with that, I'm going to go ahead and hand things over to Eden and AJ. If you'll bear with me for just a moment here, I will be making Eden a presenter and making AJ a presenter. So we have Eden joining us, and AJ will be here along in just a second. I will go ahead and stop my presentation. And with that, I will hand it over to Eden and AJ.
Thank you, Charles. So a quick introduction for me and AJ. So I'm Eden Tesfaye. I'm a Prisma Cloud Solutions Architect. And before joining Palo Alto Networks, I was a Solutions Architect at AWS and a Solutions Engineer at Splunk. And before that, I spent some time at a company called Software AG, working with integration and IoT platforms. So I'm thrilled to be here. AJ?
Hey, how's it going? My name is AJ Chambers. I work here at Palo Alto with Eden, same team actually. I also was at AWS prior to coming here. But prior to that, I was at Cisco and then a whole bunch of other networking places. So my background is primarily networking, which I suspect is probably true of a bunch of folks in the, in our Palo Alto, fuel user group here. Great to be here with you guys this afternoon, though.
Awesome.
All right. I guess with that, you know what? I'll be the one sharing. So let me go ahead and do that. Let me see. Just first time using the system, so just bear with me a little bit. Well, I guess second time since we did the dry run yesterday. Hopefully, I can get a thumbs up on being able to see this.
You are good.
Sweet. All right. So what we'd like to start with here is we're going to go over an overview of what Prisma Cloud is. I suspect that some of the attendees have probably not heard of it, or if you have heard of it, maybe you haven't done a lot with it. And then we're going to talk a little bit about DevOps and why securing CI/CD pipelines and DevOps is important and what that can do for you. So with that being said, let's get started. So this is a high-level overview of what Prisma Cloud's architecture looks like. So if you look here in the kind of the top center of the slide, we have Prisma Cloud kind of sitting here, and so we have a Prisma Cloud self-hosted version, it's Prisma Cloud Compute, which is a small subset of this. But primarily what we're going to be working with, what we're definitely going to be working with today is Prisma Cloud Enterprise version, which is a SaaS solution, right? So that's being hosted and managed by us here at Palo Alto. What we're going to be doing with that is we're going to get metadata telemetry coming in from your, workloads, your applications, APIs, public clouds, all the usual suspects, right? AWS, Azure, GCP, Oracle. If you're an international user that works in China, you'll recognize Alibaba Cloud. We support that as well. All the DevOps tools and usual suspects there, right? Our Bitbuckets, our GitHubs, GitLabs, Circle CI, VS Code. We have plugins for those types of things. Jenkins. One of the things that actually is kind of interesting in the way that Prisma Cloud works is that it is a security tool and it's useful for security personnel. So like in your DevSecOps pipeline, the security operations folks, and they get the Prisma Cloud console and they get their security tooling there. But because of what we're trying to do here is we're trying to secure from a code to cloud deployment that your developers, as they're writing code, as they're working in and developing, the Terraform code, and they're working their IDEs and they're pushing things to Visual, up to GitHub, and they're writing the things in their Visual Studio Code, IntelliJ IDEs. They're going to get actionable insights, and we'll show you that during the demo of, here are things that you could be doing that would make your code more secure, right? That is one of the powerful features that I believe that comes with Prisma Cloud is that, we're saying, hey, you should be shifting that security leftward so that you're catching things as you are coding and building and not having as many incidents up in runtime, especially when you're talking about infrastructure as code, because you're writing those templates, deploy them tens, hundreds, maybe even thousands of times. And so catching a problem with your template while you're building the template early on in the cycle could save you from thousands, literally thousands of issues at runtime. And so that's what we're doing. We're pushing those tools down to the developers to get them that real time kind of, hey, this is the stuff you need to be doing. And we're surfacing those insights in the tools that they're using. We're not just giving them alerts to say, you got a security problem, go log into Prisma Cloud Console and take a look at it there. Now, they could do that, right? The developers have the option to do that. You give them access to and have them log into those tools. But, most people's developers, they're already using enough tools. So what we're really trying to do is make sure they can get those insights in the tools they use every day and not ask them to run and use other tools, right? So as far as that goes, we do that with a mix of, inside the cloud with agent-based and agentless security scanning. So we can actually install, we call them defenders in Prisma Cloud, agents on various workloads. So you can do that for, serverless functions can have defenders that protect them. So your Lambda functions, your Azure functions. You can actually have container embedded defenders so that if you're running containers in a container as a service platform, like AWS Fargate, for example, where you don't have access to the underlying container host, you can still be protected. You can still have the same sort of policy for those containers as you would for hosts that you own that you have a full agent embedded into. So that is something that you also can install. And then we can protect hosts that don't even run containers. So you actually can deploy that there as well. So that's, Docker host. And then also Kubernetes host, for the container host, and then just any sort of Linux host. We support multiple different orchestrations. So we're going to support, Kubernetes as an orchestration platform, OpenShift, VMware Tanzu. And then, like a lot of products these days, we're going to have the AI ML engines that are actually enhancing our security. So what we do primarily with that is we're looking at behavioral characteristics of the things that the cloud, your assets are doing in the cloud. And specifically for container workloads, we're going to look at 24 hours of what the container is doing and build a behavioral baseline so that we know how the container is supposed to behave. And so that's going to help us if the container is then compromised during runtime and starts doing something it doesn't normally do. We can alert on, which is the default behavior. We also can, block or prevent. And those means different things. So like if you block, it just, that's going to, or prevent rather, it's going to keep you from running the action. It'd be like, error, like access denied kind of thing that you might get if you have a permissions issue on your Linux system. Whereas block will actually just turn off the container. And if that is a container, it's under orchestration. It's not generally a big problem because if you turn the container off because it's got some kind of in runtime compromised event that happened, you're going to start anew with a container that doesn't have that in runtime compromised event. The attacker will have to, compromise again, especially like I said, if it's orchestrated. The other thing is that, we are still part of Palo Alto Networks. So what that means is that our threat intelligence streams, it's not just coming from, the usual suspects. We have Unit 42 threat research that's feeding into that. We get to take advantage of that just like the rest of our products. We're infusing that intelligence. So you're not only going to get, CVEs that are surfaced, sometimes you'll get intelligence in there that is labeled with, instead of a CVE number, a Prisma number, right? And that actually means it's coming from our Unit 42 threat research. And so this may be a 0 day that we've discovered and hasn't actually made it all the way through the process to get a real CVE number yet, but we're going to get you that early, right? And that stuff kind of updates in real time. So we also have, as far as the product to be able to assist you in other aspects and how it integrates, we have both inbound and outbound integration. So most of our inbound integrations are going to be things like Tenable Qualsys. So we can get the scan data from those tools to enrich the security posture that what we're detecting in your cloud environments and use that intelligence to fold in. And we also can send outbound events out to ServiceNow to help you create ticketing, PagerDuty, Cortex XSOAR, which is our SIM tool, Splunk, which is a SIM tool that is probably more widely used, right? So we integrate either way. And then we also can just send, for some alerts, you can have high priority alerts. You can send those messages out to Slack. You can do it via email. If you use Microsoft Teams, you can send Microsoft Teams messages. And there's, a lot of what Prisma Cloud does, we kind of break it into, code cloud security is one module, cloud security, posture management, there's different modules that we have. The cloud workload protection module, this is the part that I said earlier, we have the 2 versions. That is primarily going to be container-based security. And, the Defender sort of engines that can actually be deployed on-prem in high security environments where you might have to be air-gapped for whatever reason, but you still need container security and defenders. You can actually deploy this portion of the product on-prem if necessary. If you are a shop that doesn't necessarily need to do on-prem, this part of the product is also in the Prisma Cloud Enterprise, so you don't have to deploy it on-prem ever if you don't want to. You can just use the SaaS version, right? Cloud network security is going to ingest all the network events, flow logs, that sort of thing, give you some intelligence there as far as what's happening. And cloud identity security actually is really powerful in this tool. It's one of the things that I really like. There's some real world example usages of that is you can model, because we're ingesting, like I said, the metadata telemetry. So we're looking at API calls, for example, coming out of AWS. So developers, a lot of times in the start of this, in your dev test cycle, they go to the security team. They go, hey, I need an IAM role to be able to do some things on behalf of, my app inside AWS. And you go, well, what permissions you need? And they go, well, I really don't know. And then you argue back and forth about the permissions for a little bit. And eventually you end up giving them an IAM role with too many permissions because no one really knows. You don't want to hamper their ability to do work. And the intention is to go back and pare those permissions down. Well, that tomorrow never comes. And now you just have a role out there that has way too many permissions. And if that asset is compromised, it has access to much of your cloud. So one of the things that cloud identity security will actually lend to is, because it has that access to APIs, it essentially, you can go in there with a couple clicks and say, what I would like to do is I'd like to look at, the last 180 days of API, last 7 days, you pick, and you tell me what this role should have access to. And it'll look at all the API data and what the role has actually been doing. And then it can then suggest to you, and say AWS, for example, it's going to give you a JSON template you can copy and paste directly into the console to change the permissions, give it to you in CloudFormation, which is AWS's native infrastructure as code language, or give it to you in Terraform. And then if it gives it to you in those reusable kind of Terraform or CloudFormation, you can then use that for, say, production, right? So then you can pare it down when it comes time to run that application in production, right? So it's, one click takes about 10 seconds to actually generate that. And it's generated live based off of, the historical API data of what that app has been doing. And so that just allows you to kind of do the thing that, you intended to do, but people get busy and they don't have time to comb through, the 10,000 permissions that are available inside of AWS to figure out which ones the app actually needed. And so that's, I feel like, pretty powerful. It also allows for the cloud identity and security engine. We have features just-in-time access built into the platform. And so what that allows you to do is you could say, as a policy now at our org, no one gets administrator access to the cloud, right? You don't get it. And the way that you get administrator access, if you need it, is you go through the tool, you request a just-in-time upgrade to admin access, you justify why you need that just-in-time upgrade to admin access, and then it's time limited. It goes to someone to be approved, or potentially could be auto-approved, but it is at very least logged. And then you were then given credentials that allow you to access the cloud with the permissions that you now need, the elevator permissions, and they expire at the end of that. And so that just allows you to actually, create those situations where folks aren't operating in the cloud because of the role that they have with admin access all the time, because primarily you don't need admin access all the time. And since these are all now time limited and logged, you can trace back when something does happen, like where it happened, how it occurred. So with that, I know that we have the audio muted here, but I did want to take a moment to allow folks to ask any questions if there's anything that you might have want to hear a bit more about, or anything that's confusing, or just something you might want to just learn a little bit more about.
No, we haven't gotten any questions in the chat yet, AJ.
All right. Well, if we get something, Charles, if you don't mind, just speak up, and I'll stop and I'll address it. So, but we'll keep moving on.
You got it. No problem.
Okay. So if you guys have questions, please do ask. All right. So now I just want to talk about, why do we use Terraform? What is it that we want to do? Why do you want IAC? What is the issue with this, right? I'm not going to read the slide to you. You guys can read the slide, but it boils down to the reason why that you want to use something like infrastructure as code is that, you want consistency, efficiency. You want to be able to actually version control your infrastructure and how you're deploying the infrastructure. You want to be able to, you're gaining consistency by using a templatized, Terraform template to deploy all your assets, right? You're actually putting that in version control, so you can see, how it's evolved over time, who made the changes. You can comment as to why you made the changes. You keep track of all that. A lot of people like to call that self-documentation, right? So like the actual infrastructure itself, the things that set up the infrastructure, self-documenting. They'll tell you why it's set the way it's set. And it also just allows you from, an efficiency point of view. Like I said, you can kind of make these things, especially for something you need to stand up a whole bunch. You can make it once and then you can deploy it tens, hundreds, thousands of times. You gain a lot of efficiency there, right? Now, as you can imagine, the problem with some of the times with being able to gain the efficiency and be able to gain that kind of ease of deployment is that, once you have something that you can in seconds deploy across your enterprise, thousands, tens of thousands, thousands of times, 10,000s of times, you can deploy it wrong that many times. And so it becomes really important to make sure that we're not introducing security problems with our infrastructure as code, right? That we're not, and that's where Prisma Cloud is going to come in. This is where we're going to, put CI/CD, our security practices in our CI/CD pipelines, right? So the other thing that Prisma Cloud will do with your CI/CD pipelines is it'll secure the actual CI/CD tools themselves. So it's going to go out and actually, when you onboard your Jenkins server, for example, it'll tell you if you have, an old version of Jenkins that is vulnerable that maybe you should upgrade. It's going to tell you if you have security settings in your Jenkins that maybe you shouldn't be using. It's going to tell you if you have security problems in the GitHub actions that you're using, right? Like maybe you're not really pinning to, known good repositories. You're using like some of the version flags. It'll let you know all those things so that you can see these kind of security problems and the things that they might, the issues they may cause you going forward, and it will surface those things. And like you said, it's going to do a lot of this, both in the console for the security professionals, so they can then take that back to their dev teams or infrastructure, tooling teams, and tell them what's going on. And then also it's going to surface these findings in the tools the developers are using to give them the intelligence there, without having to have them go and log into, separate security tools to get those findings. So it's going to surface that stuff right where they're working, which, I feel like it's pretty powerful because it's sort of, bridging the gap both ways, because developers aren't out there making insecure code because they're just bad at their job, right? That's not what's going on. Like they're doing the things they're doing because they think it's the right thing to do. They feel like this is how to accomplish it. And all we're doing is we're saying, here's a tool. It's going to help you think about some things that maybe you weren't thinking about before and surface those findings, the same way spell check might work. And Eden will show some of this in her demos whenever she shows you, her day as a developer, using Prisma Cloud. And so again, if we come in here and we're looking at, integrating Prisma Cloud into these CI/CD pipelines and infrastructure as code and that sort of thing. Again, I'm not going to read the slide to you again because you guys can read it, but I do want to just draw some attention to what we're looking at over here on the right-hand side. And what we're seeing here is that this is a screenshot of VS Code. Inside of VS Code, what we're seeing here is, in real time, right? Got a little underline, it's telling you what the problem is. And then it's going to have a link, let you go explain more of the problem. If you don't really know what it is that it's saying to you, have a better page to explain in depth what's going on. The other thing that's going on, though, is that this same sort of problem that's surfacing here, this same exact finding, right? If you push that in VCS, it goes into the actual repository. At that point, it's going to show up inside of the Prisma Cloud console for the security professionals, right? So I don't want to alarm anyone who does development, right? Like it does do this in real time. This portion is done in real time for you as a developer. You're going to get these insights as you're working, right? But it's not going to in real time, tattle on you to the fun police or, security folks, right? And say that you're doing insecure things in real time, right? It will surface these findings if you ignore all the tools and you push the code anyways, and they'll start seeing it in the tool. But it's just, I just wanted we just show this just to show, that what we're seeing is the same sorts of findings that you can get as a developer while you're working in the tool that you work in. You're going to get those they're going to get those insights and that, information as a security personnel who has to actually help secure this stuff in the back end, right? So I feel like that's pretty powerful. It actually just really allows for, like having those teams meet somewhere, right? Like it's sort of bridging the gaps both ways. Like you might not be the most, security fluent developer. And as a security person, you might not, know much about development. And so the tools kind of help them bridge that divide, right? And it's kind of helping you meet somewhere. Because the other thing the tool's going to do as well is like for some of these things, we're going to be able to issue one-click fixes, okay? If you could do one-click fixes because like it's a simple, security problem. Like let's say you got an EC2 instance and you didn't enable IMDS v2, the more secure version of the, metadata service, right? Instant metadata service. The tool will surface that. It'll tell you it's a one-click fix. It just inserts the lines of code to do that. And then you can move on, accept that change. Now, as a security person, I'm going to see that if you didn't do that, or if it's an old repository that we just onboarded, I'll get that same kind of insight, right? And what I can now do as a security person is I have that access to that same one-click fix from inside of Prisma Cloud, where I could say, hey, could you fix this problem for me? And Prisma Cloud will then create a merge-ready pull request inside of the VCS, right? So wherever that, Git repository lives, create that pull request there. And then that's going to kick off whatever CI/CD processes you already have. It's not going to change any of the rules. If you need 2 developers to approve that merge, request or pull request, it's still going to be there. You're still going to have those 2 developers approve it. It's still going to run whatever, CI/CD processes, security tooling that pull request will kick off. Doesn't circumvent any of that, but it does allow me as a security practitioner who maybe doesn't know anything about the code to go ahead and, assist the security team with a pull request that they can just look at and go, oh, it passed all the tests and this does fix a security problem. Yeah, approved, and that's real value there, right? Like that's developer time that could have been spent, doing something else, all right, that would have needed to fix the security problem if I just sent them an email as a security guy and said, hey, I got this finding. says you guys need to enable IMDS v2. You guys go do that, right? Well, instead of doing that, making them go and enable that, I'm now just doing it with one click, opening the pull request. They can look at that, see it passes all the CI/CD tests, and go, yeah, this actually is a pretty good, fix here and upgrade, and just accept it. This is also true of Terraform, and how Terraform is going to integrate when for running. So if you look here at this picture, what we're looking at is Terraform Cloud. So when you're running Terraform Cloud, we're going to be able to do what's called run tasks. Run tasks are just what Terraform calls it. It's just essentially going to do, after the plan's finished, it's going to run it through the security engine. And then these findings that show up here, they show up in the tool that the infrastructure engineer is using, where he can, take action, or she can take action. Look at those things like in the tools they're using. We're not asking them to go other places. And then also they're showing up for us as a security engineer in our tool. So we're getting the same insights, right? So we have those things in both places. And then with the run tasks, things kind of neat about those is that, again, you can run them either pre-plan, post-plan, is how our integration works. You typically want to run it post-plan because the way that Terraform works, if you know much about that, when it gets done planning everything, it's going to have all the account numbers in it. It's going to have all the resource tags. It's essentially going to be the exact things it's going to do in the cloud is all ready after, the plan has been finished. And so if we then do the check, then we can action off of things like this account has different security rules than a different account inside of our organization, right? So because now we know what account it's going to apply to. Pre-plan, we may not know that, because the account number may not be filled in pre-plan. It might be a variable that gets added after all the plan is done. So it's just in general, if you can do checks pre-plan, post-plan, usually want to do a post-plan. And then, like I said, you're going to get the findings are going to show up for the, Terraform infrastructure engineer right there in the tool they're using. They don't have to go anywhere else for it. And then for security person, they're going to set back, they're going to see those findings in their security tool, right? So just a nice way to do it. It's going to surface those findings in the right place for the right people. All right. So during the demo, what we're going to do here is Eden's going to be playing the role of the developer. She can show you a day in the life, her responsibilities and things that she does. Again, I'm not going to read slides to you guys. You guys can read. But Eden's going to play the role of the developer. She's going to show you what she does day to day, how she actually uses these tools and where they interject themselves into her workflows. And then I'm going to come through as the SecOps engineer and show you, how those tools work for me in my environments and the way that I use them. So with that being said, I'm going to go ahead and stop sharing here so Eden can start sharing her screen and she can show you a day in the life.
Fantastic. Thank you, AJ. So let's get started. I'm going to share my screen. You might see the video of us pop up really briefly. And you just let me know when you can see my screen.
You're good.
Yep, gotcha.
Okay. So as AJ mentioned, I'm going to be assuming the role of a developer. So I'm going to start off by forking this repository. Now, this repository is going to create an EKS cluster, 2 nodes, and it's going to deploy a demo app on top of it. So let's go ahead and fork this. And this is, let's just do fork 3 and create the fork. Now, as that's going, the next thing that I want to do, I know that within that repository, there are GitHub actions. And so for that, I'm going to need to integrate those actions to Prisma Cloud. Now, you're going to see some of this, the access keys and the secret keys pop up here. Hopefully, you're not a threat actor, but even so, these are short-lived and we're going to revoke them. So I'm afraid you won't be able to do much damage if you are. So let's start with populating this. So that's going to be the access key. Next, we're going to grab the secret key here. Make sure there's no spaces. Next thing we're going to do is the Prisma Cloud URL. So we'll do that. And the next thing is going to be PCC SAN, or the subject alternative name. Let's make sure there's no space. And then the next thing we're going to do is the actual key. So the access key and the secret key concatenated. So we'll do that. Again, make sure there's no space. Perfect. So now that we have that configured, the next thing that I want to do is I want to work on this locally. So I'm going to go ahead and I'm going to clone this repository, pull up my terminal here, and let's make a directory first and do HashiCorp demo, as that's what the repository is called, I believe. Let's go ahead and go into that repository and then do git clone and grab that. Perfect. So now let's make sure that we have cloned that. We have, and now we're going to pull up our Visual Studio Code. Okay. And now we see that here that we have our new cloned repository. So let's just explore how Prisma Cloud comes in here. And as AJ mentioned, how it course corrects the security risks that we are introducing or we may introduce unknowingly. So you'll see here at the bottom of the screen that checkoff is scanning. So we'll give that about a minute.
Hey, Eden, just real quick, could you show us the actions in GitHub that it's going to be running?
Yes. So we're going to enable this so
Yep.
that when I do make a change, it does invoke an action. So we have problems, and you can see here what we're looking at is it kind of looks like a syntax error. So the same way that developers are able to see if they've made syntax errors in the code is the same way that checkoff is going to surface these findings. And so what this tells us is what Terraform module sources do not use a Git URL with a commit hat revision. So something to note here is that, well, there are a lot of different services that we leverage in AWS and maybe a lot of different Terraform modules that we leverage. And I, as a developer, may not be familiar with what this means. So for that, what I'm going to do is I'm going to click on the link here, the checkoff link, and it's going to open up this link that explains what this means. Why is it a security risk? And essentially, and I've read up on this as the developer before this demo, so what this tells us is that, well, using a source and a version is not secure because, well, these are public registry modules, and if somebody makes a change to this, that doesn't tell us, like the version doesn't tell us that it's been updated. And so for that reason, what Prisma Cloud is suggesting is that we take out the source and the version and instead replace it with a SHA hash, right? A commit hash, so that we know that this module is revised. And now I understand that this module is coming from AWS, which is a trusted partner. So what I'll do is I will generate a skip comment. And I'm going to add a reason. So AJ, the fun police, does not come after me. I'm going to say here, module is from a trusted partner. And I'm going to save it. And presuming I made other changes to this application, and I'm going to go in and I'm going to commit this. Actually, let's give a message here, and let's just copy this and paste it. We're going to commit it and sync changes. And now, as AJ mentioned, so all of the checks that you saw here, they were local to my IDE until I just did this. Now I've committed this to my GitHub repository. And now AJ will be able to see that I have committed this, and I've put a reason for why I'm ignoring that security check. Another thing I want to mention here is that we have checkoff configured also in our GitHub environment. And so what that's going to do is the same checks that you saw in the IDE that we showed you, kind of like a syntax error, well, it's going to scan all of the files. So instead of just checking that IAM Terraform file that I opened, it's going to scan everything. And so we can look at that here in detail. And we'll see that checkoff has scanned this, and we'll see the findings, right? We'll be able to see, where we failed and why we failed and how that maps back to the policies that we've enabled in Prisma Cloud. Now, this is an okay way to look at it. And of course, if you're a terminal person, you might not be off put by this. But another way that we can do this is we can actually output this to GitHub security, and we can look at it in the code scanning view. Right, so what this gives us is just a cleaner view of what we've done wrong. So for this CVE, for example, we may need to bump up the version for the Django 1.2. So it just gives us a cleaner view into what the security checks have failed.
Hey, Eden, if I could just
So
throw
now
a
that
quick
we've done,
question at you. This isn't from the
yeah,
chat. This is actually from me, just for clarification for the other people listening. For those who aren't aware, what exactly is checkoff?
yeah, great question. So Checkoff is the open source CLI solution, and it's a plugin. So it's supported, I believe, in the IDE's VCS code and IntelliJ that you can install. And what it will allow you to do is scan the same scans that I have done. It will allow you to scan your code for any misconfigurations, secrets, and so it does that for IAC. Now, the added advantage of having Prisma Cloud is, and AJ is going to, of course, demonstrate this, is the consolidation of all those findings to one central panel, and then being able to define your own policies. So enhancing the out-of-the-box policies that come with Checkoff, also advanced detections that come with Prisma Cloud, and being for AJ to have that visibility into what's going on within our development environment.
That's great. Thank you. Yeah,
Did that
I just
answer?
want people understand that, and correct me if I'm wrong here, but checkoff is not part of Prisma Cloud. It's a separate item completely.
Well,
It,
so a
it,
little bit, right? So let me go just jump in just real quick, right? So it is and it isn't. So we're using it in Prisma Cloud to do the scans that we're doing. So like when you connect outward from Prisma Cloud, right? It is the basis of how we do all the scanning. And so there's a free version, as Eden mentioned. So you can get the CLI version of it, run it wherever you'd like to. You can do that for free. But what Prisma Cloud is going to bring to the table is that, again, when we showed that kind of overarching, architecture, it's policies, right? When you create the policies and you create it in your Prisma Cloud console, that is going to communicate it to everyone who is tied into your Prisma Cloud instance using the checkoff utility. So that API key that Eden had put in for GitHub, that's what actually is tying it back to using our Prisma Cloud instance for that particular, checkoff version. And so if we had, special policies, right? If we created policies that were specific to our organization, they would then be pushed to and applied during the runs, as well as being able to upload the results back to our console. So it is available as a separate tool, but it is the basis and integrated deeply into Prisma Cloud and how Prisma Cloud is providing that code security.
Fantastic. Thanks for the clarification, guys. I appreciate it.
no problem. Keep them coming. Awesome. So now that we've went over that and we went over GitHub, let's move on to Terraform Cloud. So Terraform Cloud is a SaaS offering from HashiCorp, and what it allows us to do is define projects. So it allows us to scale our Terraform efforts across our enterprise. It allows us to standardize, and it gives us isolated environments where we can collaborate and we can also deploy our infrastructure in their respective environments, right, in different AWS accounts and such. So now the first thing that I'm going to do when I come into the workspace is go into new. I already have a project, so I'm going to create a workspace. I'm going to pick my project and go ahead and enable the GitHub integration to the repository that we just forked and we made changes to. So I'm going to go ahead and create that. Now, the next thing that I want to do is apply the variable sets or the variables that my Terraform file is going to need, or Terraform is going to need, in order to run the automation that I wanted to run, in order to deploy the infrastructure, the EKS cluster, into my AWS environment. And before I get ahead of myself, I think I did mention that it is an EKS cluster that has a demo app running in it that we're using today. So just making sure that I've covered that. So we're going to go here and we're going to go to variables and apply the variable set that we've already defined for this demo. And the next thing that we're going to do for this workspace is go into settings and enable the run tasks. But we want to make sure that Prisma Cloud, as AJ mentioned, runs post-plan. We want to make sure that the Terraform plan is good. There's no configuration errors. There is no dependency conflict, right? So after that is when we want to enable Prisma Cloud. Now, again, we've already integrated Prisma Cloud to our Terraform cloud. It's an out-of-the-box integration, and it takes few minutes to integrate this. So I'm going to select Prisma Cloud, and I'm going to specify that it is post-plan. Now, the enforcement level is very important because, well, we want defense in depth. We want to be able to do something and not just be alerted that something is happening, right? And I know AJ would love this if it was mandatory, but AJ is being a little lenient with me because I'm developing this and deploying this in a development workspace. So we're going to leave it at advisory, but just a note for you to take that you can make it mandatory so that you can enforce that these policies be remediated or these findings be remediated before it is allowed to run in Terraform. So let's go ahead and save that. Perfect. So now what we're going to do is go back into the workspace, and we're actually going to do a new run. Okay, so it's going to start running and deploying these resources for me. Now, this takes a little bit to run. So what I'm going to do instead is I'm going to go back as this is going. I'm going to show you one that's already ran and show you what this looks like in a developer environment. How do we look at these findings? So you'll notice here that we have an advisory indicator. And what this is telling us now, we made it mandatory, this wouldn't have ran, right? The Terraform apply would not have finished. So here what we're looking at is this finding. So we are to create 50 resources, and there are some findings within this Terraform files, within the Terraform files for this application. And as a developer, the last thing that I want is to learn another tool, right? To be able to have to navigate to a different source in order to find out, what's going on. So for that reason, if I want to, I could. If AJ has provisioned, role-based user access for me to where I have view only into my repository, which he could have done, then I can go in and I can actually look in Prisma Cloud and see where those details are. But I can also just look at these findings from this view. Now, the same view, the same policy doc that you saw within the IDE that I clicked on is going to be available for me to preview here as well. So if I click on this, it'll actually go in and give me the checkoff ID as well as how that maps to the Prisma Cloud policy ID and give me a description and guidance around what I should do to fix this. And this is really important because, well, as AJ mentioned, developers are not people who don't understand, how to do things, but more so there's just a lot of things to do, a lot of new services to learn, and learning how to secure those services on top of, creating applications built on those services is a tall task. And not to mention, these services are constantly updated. They're constantly changing. So not only is Prisma Cloud providing guidance to AJ on what kind of security enforcements that he should enable, but Prisma Cloud is also providing me guidance around, what my responsibilities are in securing both my infrastructure and my code. So now that we've looked at this, I'm going to pass it back to AJ so that I can give some time for my infrastructure, my Terraform to run, and we'll come back and look at what this has done for us after it's finished.
All right, appreciate that. Let me go ahead and get my screen share going again. Entire screen, this screen, and we'll okay. Hopefully everybody can see that.
You're good. Yep.
Good. All right. So I'm going to start my day as a security engineer, right? Everything's going great, right? So what happens here is I'm going to log in, and I'm going to be here at my Prisma Cloud, welcome to Prisma Cloud main screen, right? So I know that Eden's been doing some work, and so what we're going to do here is we're actually going to go in and take a look at the work that Eden has been doing. We don't really have any current incidents. We got some patchable vulnerabilities. This is my dashboard when I come in, right? So I know that she's been doing, application development. So I'm gonna come over here to my application development view, and specifically, I'd like to take a look at some of the things that Eden's been up to. So I can go and take a look at the checkoff results from her repositories, right? So I come down here to projects, and then I can go look for. Actually, we'll start here, repository, since we're going to look at that. I know that this is her organization, so it's just easier to find her stuff if I go here. And so just go to Eden's organization, and then I can take a look at her demo fork that she made, get a little bit of details about what's going on there. We can take a look at the technologies that are there, the deployed images, and then over here, I have all my issues, right? So if I want to go ahead and select the issues, the reason why I did that, it's a little bit easier just to get straight to the issues, right? It's going to take me to the same spot. I could have navigated to those projects, and I can see largely the same kind of things that she was seeing, right? So I look in here, and I can go, okay, well, what's actually going on with this? Well, we got a VPC. VPC is Terraform module, doesn't use Git URL, which we went through that. I also have access to the same policy documentation, so if I want to take a look at that, because I'm not really sure what that means, I can get it here. This is not something that we can fix automatically, right? So this isn't something that's gonna have an automated fix, unfortunately. But like I said, the gist of it is, like Eden said, right, is just that version tags are not immutable. If a bad actor got a hold of this repository, they could retag any Git version, or any Git commit with the version tag, and then I would just use that if I went to go run this. So instead, we're saying, hey, why don't you just use a SHA hash Git commit, because that's immutable. Bad actor gets a hold of it, they can't change that. So it's just a little bit safer way to do that. But like I said, Eden was right. AWS is a trusted partner. We trust that they're going to keep their GitHub repository secure. And so we're not really that worried about it, because you do lose a little bit of flexibility when you're linking directly to the the version tags, because one of the things that you do with the SHA versions, right, is that you can just say, hey, greater than equal to, give a range of versions that you'd like, that sort of thing, right? So you actually can gain some enhancements if they make some enhancements to it. So you do lose a little bit of flexibility whenever you link directly. If I go back to overview for this particular one, right, we'll get some other kind of findings that also run, but weren't output directly in the in VS Code, right? So one of the things is we have a license tool. So this license tool is going to go through and to give us findings and say, hey, look, you got a problem with the license. The license that you're having a problem with is that it is not OSI approved. And if you're like me, you think that's Open Systems Interconnect because you've been doing networking for too long, but that's actually the open source initiative. So the open source initiatives, got some approved licenses. And what they're saying is, hey, if you're trying to release open source code, right, and you want to do open source code, there's certain types of licenses that OSI approves. So you can get these, out as well, suppress them if you'd like to. It's totally fine. Either way, right? So in general, though, right, like we're getting the same sorts of things that Eden was having surface for her during her time using the tool inside of GitHub. We're getting those as a security engineer in our view. So we're actually able to see those same sorts of stuff, right? We got EKS, Terraform file here, Terraform module finding, same module. A lot of the finding is going to be that we use the version instead of actually, linking directly to a SHA hash. So a whole bunch of these could just be fixed by doing those skip comments. We also have a button down here inside the GUI where we can hit suppress. And so if we suppress it, we're good to go as well. It'll then disappear. So next, what I would like to look at is I'd like to see the Terraform, run task, right? So if we take a look at the Terraform run task and look at CI/CD run, because this is where the surface is, or the findings going to be surfaced for that. The view that Eden was looking at inside of the Terraform cloud, these are the actual findings that were there. So these are a little bit different. They're not really complaining anymore about the fact that the module itself has got a problem. And part of that is because this goes again to the post plan. When the plan is finished, it actually has everything it's going to do inside of AWS, right? And that's the important thing to remember. The thing that Eden was actually running and was taking a little bit of time to run, when it's done, there's going to be an EKS cluster, so a brand new Kubernetes cluster up and running in AWS that's going to have defenders installed to tie itself back to this particular console, and then also has a test app running on top of it, right? So there's going to be containers running in there. We're going to see some findings on that in a little bit. And it might even be populated by the time we get over to the runtime security tab here in a moment. But the other thing that happens, though, is that the entirety of whatever it's going to apply inside of AWS is available to this particular tool at that point to do some investigation. So what I'm doing is I'm doing a shorthand module in the Terraform code to make some IAM roles with policies attached, right? And so those aren't just available in the .tf files that you would see inside the repository. But when the plan's finished and the plan file is done and is a JSON format, it's about to be applied, the actual entirety of the IAM role is available. And so now we can get surface findings that are things like, hey, your IAM policy is, has restricted actions, allows all resources with restriction actions. So basically, the gist of this, if you want to read it, you can. But essentially, the gist of it is saying, hey, you're restricting the actions that things are allowed to take, but you're allowing those actions on all resources. You really shouldn't be doing that. You really should be narrowing it down to the resources that are required for that, right? And so that's something that you're like, oh, okay, well, I can go change my Terraform code and I can restrict some of these now. So it's just, helpful findings about some stuff. And sometimes like you do actually want some action to be available. And in that case, if you want that, we still have the suppress button. You can just say, hey, this can go away. We don't need to hear about this one anymore. And it will suppress that one on that resource. So that allows you to kind of see that in real time. Next, like I said, because the thing that Eden's doing, at the end of it, there's going to be runtime assets, right? There's going to be stuff running in AWS. So if we come here to our runtime security, go over to the radar view, we're first going to start down here in defenders. So you probably notice there's a few different defenders. These take a little while to age out. These are some clusters that we stood up and tore down just for purposes of fleshing out the demo, making sure the demo is good. So Eden's new cluster hasn't totally stood up yet, but we do have a cluster, and this was the run task that she showed you that finished. And we also have a container defender, which is a Docker host. It's also just running in the cloud. So we have 4 hosts here that are currently connected, right, with defenders. And these 3 hosts here were set up with that same EKS template, Terraform template that Eden showed you guys just a moment ago. And if I come over here to our radar views, we can see the hosts that we have in the cloud. Now, notice I just said that we had 4 hosts. We had 4 defenders. But if you're quick to count, you can see there's 5 hosts, right? Well, why is there 5 hosts? Well, this goes back to what we were talking about before about agents versus agentless. I have this Prisma Cloud pointed at my AWS account, and so I deployed an EC2 instance, and I deployed that EC2 instance without installing a defender. Well, I have policies in place inside my organization that says if they don't have defenders, we're going to do agentless scans, right? So I'm still getting those same types of insight. It's a little bit less insight because obviously the way that the agentless scan works, it's more of like for the network folks out there, I'm going to equate it to an IDS versus an IPS, right? We could do the detection. We can't necessarily do the prevention because in order to do the prevention, you need to have the defender running in real time on the host to be able to defend against things in real time, right? But we can definitely detect things. So you get that whether the agents get deployed or not. And so this is also really good whenever you have in cloud environments things popping into and out of existence. And so we get same sorts of findings. This particular host doesn't even run containers. So it's again, it goes back to what I was saying before. We could defend hosts that don't even have containers running on it. These other things that are here, this is a Docker host. It's going to be running, it's got Docker images on it. You can see the little, I don't know how visible this is, but this little loopback link right here. It's actually a health check. It's the defender's running on it, and it understands that it's actually made a health check back to itself, so it's depicting that for you. It's red because it has some amount of vulnerabilities and compliance problems. You can click on those, get more details if you'd like. Vulnerabilities is just, we got old versions of Python on here, different libraries that wants to upgrade some of those. And then same thing with, we go to compliance, take a look at the compliance problems. We got authentication required, CIS benchmarks is where some of these things are coming from. Just giving a service as various findings. Same thing for our Kubernetes hosts. So these are the Kubernetes hosts that were set up as part of the EKS cluster. It's actually running our workloads. We're seeing things, populating there. And if we go to container view and we go back to all clusters here, while I was talking, right, what we'll notice here is that Eden's cluster came into place, right? This cluster has been here for a little while. So we'll go ahead and take a look at this one real quick. We come into here, it's going to have all the namespaces. So the default namespace is where we are deploying our demo app. Here is our demo app in deploying. This is the Defender itself, because the Defender itself actually runs a container. So it's also a workload inside of the cluster. And if we take a look at any of these guys here, we take a look at our compliance. We have a finding here because the image was actually created as a root user. Really shouldn't do that. This is just a publicly available image. It's being run as root. If you're running like Rancher or something like that, like where they have security policies, you likely won't see that because Rancher typically enforces that you don't run as root. And then this is the database for our test app. And this here is going to be the actual application. It's a Node.js app, and I'll pull it up here in a moment and show you guys what that actually looks like. And then, like I said, if I go back here to clusters, take a look at this fuel user group cluster. We haven't quite got the app populated yet. So if you look at how the deployment actually goes, it's going to actually, wait, we might be all right. It might just be that it's filtered to namespace. My bad. So it was just filtered to a namespace. So this is actually the cube system, twist lock. There's the default namespace hasn't showed up yet. And honestly, now that I've cleared that, you guys can also see these are the containers that are running in the cube system that are doing things like CSI node driver, right? So this is the container storage interface, and so these are all the things that actually make the underlying Kubernetes run as well. Typically, you end up hiding a bunch of these because, I mean, honestly, you don't have a lot of option on where you're going to get your EBS CSI driver, right? If you need EBS container storage interfaces, you got to run this container. So, it usually just clutters up your view. And I know it drives security folks wild, but it's probably better just go ahead and hide that one, right? And then, like I said, to go back to kind of what we're talking about here, if I go to my AWS console here, like this is actually deploying real things in AWS. Like this, these things didn't exist and now they exist. So this is the actual demo cluster that is deployed in AWS. And if I come in here and I want to take a look at the resources, I know that I deployed a service. That service was that demo app. It's right here. It's called app. This is the URL for that particular service. I could just click this link and try to follow it, but it's not all that helpful, partially because what's going on with it is it's going to open up an HTTPS link. I don't have a certificate created for it. I didn't go through the trouble. So I usually just copy and paste it and delete our S here. And then if we go here, this is an actual live running app. So this is what it actually deployed. I'll go ahead and copy and paste this. I'll throw it in chat. So if anybody wants to, you guys can go and mess around with this. It doesn't have users or anything like that. So if you guys add something, it'll show up here as well. Right. So if I do like a test 3, hit submit, it's going to just show up here. But that's live running, like I said. So what at the end of the day, we forked a repository, had all the security tooling integrated with Prisma Cloud, and it went from a Terraform template that we took off of a repository, inserted some environmental variables and things to help with the deployments, and then ran that through both a GitHub Actions to do some code security type scanning stuff, to all the way to deploying that with Terraform Cloud, and Terraform Cloud then deploys and makes these things available inside of AWS, creating entire EKS clusters that just weren't there before. And then, oh, by the way, while it's doing that, it's also deploying the defenders that allow it to actually be protected by Prisma Cloud. So
yeah, and just to add to that, as my application continues to run, I think I've got about a minute left. Both AJ and I saw a question in the chat that talked about Terraform Sentinel, right, and how we differentiate ourselves from that. And as AJ and I had experience in AWS, the one thing that's difficult for our cloud customers in the cloud is there's really no uniformity to their security strategy. And what AJ just showed you in that view is that he was able to have visibility essentially from code to deploy. We haven't really gotten into the cloud operations and continuous monitoring stage of the cloud just yet, and that's not covered in this demo because we wanted to make sure that we emphasize, what security looks like throughout the life cycle of Terraform development and deployment. But it also ties back when we get to the cloud is the continuous monitoring, being able to identify a root cause and, what caused that issue? What repository does that issue exist in within minutes? Threat actors in the cloud, it takes them about 15 minutes to exploit your environments and make lateral movements. So I think that it's really important for us to understand that, these point solutions that are really meant for a tool, it doesn't help you scale your cloud strategy to fit the dynamic nature of the cloud. Right? So I just want to make sure that we that I wanted to make sure that you all understood that. And with that, I can show you the application now that it is finished running. So AJ, if you want to...
I'll go ahead and pass it back to you so you can show them the brand new cluster we set up while we were talking.
Yes. Okay. Let me go ahead and share my screen. I'm going to minimize that. All right. So as AJ mentioned, it's going to be the same demo app that he showed you, right? But this all ran and it's auditable, meaning that AJ can go back and still scrutinize. It's not something that is siloed to a solution. He has those findings in his platform to where he can come in and he can scrutinize what I've done, right? How I've skipped this. And it is advisory. So he's offered me some leniency here. So once that is done, we can go into our EKS and go into services and get the address for this. And like AJ, I'm going to go ahead and copy this and take out the S out of HTTPS, or maybe it will let me do that. Now let's go back and refresh this because maybe I don't have the.
You can just throw HTTP in front of it to force it.
Yeah. Okay, let's do that.
Yeah. It could be if it just now stood up, even if you want to take a look at that app, it does take a little while for the load balancer to stand up.
Yeah.
Sometimes like it takes about 10 minutes or so for a new one to stand up. So, and the point is, and this is actually something I used to cover a lot when I was at AWS, right? We talk about this all the time, that you can stand things up in minutes, seconds and stuff, and in the cloud. And that's true, but sometimes it's, tens of seconds, hundreds of seconds. It's not exactly, a second, right?
Yes, exactly. So now we have that application up and running.
If you want to share that link, you guys can, with the chat, if you don't mind.
Yeah.
You guys can throw some stuff in there. You can see that, right?
Yeah. Okay, so I will stop sharing now, and I will share this information.
Yeah, so it looks like Bruce had a question about inbound, outbound security groups configuration with Terraform. So it will surface that in some instances and complain about, security groups and how the security groups are going. I don't think that we actually, because it actually does. So there's security groups that are part of those templates from AWS, and they're fairly locked down. And so they probably met the definitions for the checkoff, scans. So it might be why we didn't get any alerts on that. But that is a thing that'll be done. And then the other thing though to keep in mind as well, Bruce, is like we were saying earlier, one of the things about checkoff being open source and being available versus checkoff being integrated in the Prisma Cloud is that if we don't provide a check that you would like, out of the box, out of the open source, you can write it, right? It's very extensible. There's, dev guides to it. Sometimes what folks, like a real common one that does get provided and usually gets written by folks, is that they want every resource deployed to be tagged. And they want every one of those resources deployed to be tagged with certain things like dev test prod, for example, right? Sometimes they want, another tag to be, not only are you tagging with dev test prod, you're going to tag it with the department it's from, right? For billing purposes, whatever. And so you can actually have that be part of your Terraform checks, right? And like Eden said, if you make these mandatory checks, you can make that a check that runs that is a blocker. It'll say, hey, tag the stuff, and then refuse to allow you to deploy your Terraform
until you fix it.
Yep.
And also, if you miss that, and that's really the great thing about Prisma Cloud. And when we say you need context and you need end-to-end visibility. So if somehow, AJ let me get away with it and I put it as advisory and I deploy an application that's open to the internet, then, he would be able to catch that at the operations stage, right? And the cloud, when we do continuous monitoring, he'd be able to flag, hey, we have a critical workload that is open to internet. And he'll be able to identify the source of that, what IAC introduced that. So rather than playing whack-a-mole, right, and coming to me and saying, hey, Eden, can you go ahead and fix that and lock down your security group? What he can do is he can invoke a pull request and I can directly embed it into the IAC. And then there's another question. Does this send out alerts? It does. Yes.
Yeah, absolutely. You can get more alerts than you probably would ever want from this, to be honest. So oftentimes, like the way that we do it is the alerts are surfaced in the console, and then you can actually then apply alert rules and send those alerts to even external integration. So it'll email you, it'll text you if you'd like. Pretty much it sends you PagerDuty messages if you have PagerDuty. You can integrate it with Amazon SNS, and then SNS can send it to wherever it wants, right?
So ServiceNow, it does integrate with ITSM. And so you are able to integrate it and send alerts that way. You can also integrate it with Jira if you're looking at integrating it with a ticketing system. Could this integrate with Cortex Data Lake? So this integrates with Cortex XOR. Now, for these findings, we have an extensive REST API library that you'll be able to virtually pull these findings and push them anywhere. But as AJ mentioned, if we're looking at automating and orchestrating, we do integrate with XOR. And what that allows you to do is that if you have a SOAR platform, more often than not, what you're doing is you're getting data from like a Splunk, or you're getting data from the services themselves, like CloudWatch and CloudTrail, right? So it's siloed data coming in, and so you have to go in Splunk and create an SPL and then push that to SOAR. It eliminates all that. What it will do is it will concatenate all the alerts for you. And we didn't get into the cloud security so much, so you didn't get to see like the attack path and how we stitch together different alerts to show you, hey, this is very critical because this, can escalate to privilege escalation, or your data store can be exposed and things like that. What it'll do is it'll concatenate all those alerts and push it into XOR. And in XOR, in Cortex XOR, there are templatized runbooks in the Prisma Cloud package that's out of the box, and you can go ahead and augment that and change it as you need. AJ, anything to add there?
No, actually, in fact, though, because it looks like we got a little bit of time anyways, I'm actually getting ready to open up our demo environment that has some of the attack path stuff you just spoke about. Yay. And I can show a few of those things if you guys would like to see it. So let me go ahead and do that. So the one I just did, like in particular, right, it was my personal Prisma Cloud instance that we use to, mostly, and let me blow this up because I know it's going to be a little bit tiny. Let me get this.
The audience wants to see it, AJ.
Yeah. So, but anyways, so here though, right, this is the one that we like to show to customers, kind of show some of the attack path stuff. And so these have things actually deployed to them that are a problem, right? Like, and they're a problem on purpose. So we know these are vulnerable assets we haven't deployed. So if you come here to your overview, right? So start my day as a security guy, I got incidents. One of the incidents here looks pretty damning. SQL code injection attempts, right? Very, very long involved. Well, then I can go ahead and bring this up, and I'm gonna get what we call our infinity graph view. Okay, so our infinity graph view is gonna tell me I have an internet exposure is one of my problems here.
AJ,
and not only does it tell me I have an internet exposure.
I'm sorry. Can you zoom in just a little bit?
Yep. Can you guys see that a bit better?
Yes.
Okay. So I have internet exposure here, and then it's going to show you the entire path through AWS all the way down to the ENI for this EC2 instance that actually is part of that internet exposure. So if you'd like to go fix it somewhere, you can figure out what's going on. We have inside of here, right? This is the EC2 instance at, kind of in question, right? We're getting data exfiltration. So this is coming from, it's looking at data going out. It's like unusually high, right? Web attack. This is coming from, the WAS stuff that we have. Another web attack. So we got SQL and code injection that we've seen here. We have vulnerabilities on the actual instance itself, right? And you can expand that, check out what the vulnerabilities are. We have a misconfiguration. This is actually another one of my favorite features here. So this particular misconfiguration, this is IMDS v2. This is one that I was doing this in Terraform. We have a one-click fix for it. We also have this fix in cloud button, right? I wouldn't recommend doing that if you've done this from IAC. We have done this from IAC, and I know that because this button would be either fix in code or, because it's already been fixed in code, view details, and I'll click that in a second. But if I hit fix in cloud here, what it's going to do is if I have permissions, which you don't necessarily have to give it permissions, I can hit execute command. It'll go fix this metadata option for me. If I don't have permissions to do that, I didn't give permissions to Prisma Cloud to do that. Here's the actual command all the way down to the instance ID, everything you need. Go paste this somewhere where you do have permissions to do it, right? So give it to someone who can do it. Let them go ahead and execute this command. You'll fix your IMDS. Now, this has been deployed from IAC, not how you want to do it, because drift detection is going to happen. You're going to fix this. A couple hours later, it's going to unfix itself. So what you really want to do, and one of the powerful things of the platform, is it understands that this came from an IAC template. It has the IAC template, code repository onboarded. So it's got all that traceability inside the platform. And so if I click here on view details, what it's going to do is going to take me to the pull request that was made by the platform to fix this problem, right? So the Prisma Cloud DevSecOps bot made this, okay? And if you look in the actual file and what it did, it went to the file and found that EC2 instance, right? And said, hey, HTTP tokens required. That makes it IMDS v2. Okay. So when I say that, you don't have to know anything as a security practitioner. All you have to know is that it's a configuration item, and some of these things will just surface. Click, one button click, right, and you fix it. It'll open up and again, this doesn't actually just automatically get merged, right? It gets open like a pull request, like everybody else that would be doing dev work, right? So that's sort of the power there. The other thing that we got going on with privilege escalation, it's complaining about this because there's a role. The role is going to actually give you access to some S3 buckets. So we can see the S3 buckets here. This one's called PC National Bank. It's actually a little hard because I got it so zoomed in so far. Let me see if I can get it to the point where I can click it. Our UI doesn't do so great when it's super zoomed in, but then it's also hard to show without super zooming in on call. So apologize for that. But inside of here, you can see, some of the objects are actually in this bucket. It'll give you the overview of what they are, right? None of this looks good. PII, PHI, health data, like probably not the thing that you want, some internet exposed EC2 instance to have access to read, and especially not when it's got a data exfiltration alert going on because it's detecting high volumes of things moving out of the cloud, right? So, and then again, the identity engine here is also great. You can take a look at the role itself. So we take a look at the role itself, take a look at the identity tab here. And in the identity tab, it's going to tell you what resources actually have access to this identity, right? So there's 5 things that we know about in our cloud that are using this. It's going to tell you the permissions, the policies, right? That this thing actually has access to. And then one of my favorite buttons in this entire product, suggest least privilege access. This button's going to take you from 7 days up to 2 years, right? That's where our slider goes. And so you can actually look at however much data you'd like. And so let's say we'll look at the last 90 days. We can output it as JSON. It goes directly, into the console, AWS. We can do it as Terraform, or we can do it as CloudFormation, right? Any of those 3, hit calculate. This took about what? I don't know, 3 seconds or so. 129 of the 152 permissions were not used and can be removed. So then we can take a look at all the recommendations. We can take a look at the ones that they wanted us to keep, because that's a lot shorter list, right? And so there's 23 permissions it's going to keep. It's going to get rid of, most of, right? So 129 of the 152 permissions are gone. And if we look at the next tab here for recommendation, this is our new policy, right? We could make that a Terraform template, and then we could reuse it going forward. So this is really good if you're doing, DevSecOps, sort of the recommended way where you have dev, test, prod, that kind of thing. You can be overly permissive in your dev and test. You can give developers access to more permissions they need. You can let them pare down the permissions they're actually going to need in production. And then you can use this tool to actually pare down those permissions and use the Terraform template to continue building for prod. And then you can just variabilize the things that need to be variables, and then, set in the resources they're allowed to act on. So yeah. But yeah, so I mean, like I said, this is it sort of bridges all that gap. And and again, when I went over here to this Prisma Cloud, this particular repository here, we have a few different pull requests. This right here is updating the pom.xml, which is going to be your your dependencies. So it's going through and bumping versions on dependencies as well, right? So it's just opening up pull requests as things are going on. There's a bunch of them closed and things, because this is one that we deal with all the time. But that's the ideal behind this, right? Is that, and also when you commit and you open up a pull request, don't let the bot do it, right? It also will just comment directly on your pull request if you did something that you maybe shouldn't have, right? You go to open up a pull request, change the file, maybe you made a ACL too permissive, and say, hey, you probably shouldn't have done that. And then sometimes when it can fix it, it'll not only tell you shouldn't have done it, it'll give you a suggestion on what you could do instead, and you could just go ahead and accept that suggestion.
Hey, AJ, before this ends, I was chatting with Bruce in the chat, and he found that the path and showing you exactly what you can, what could be hit, what could be impacted, and how you can remediate. It was great, and Vulnerability Explorer is my favorite. So before you end this, I was just hoping you could touch on that.
The Vulnerability Explorer, or are you talking about like the dashboard?
Or either way, I think both ways would show it. Yeah.
Yeah. Okay. Cool. So this is our dashboards. These are quick hit ones, right? So this is kind of big overview, what you got going on, your top impacting vulnerabilities. you can go through and say, okay, well, what is this guy? CVSS 10. Okay, Apache Log4j. That sounds excellent, right? You can see you're impacted. So across here, you got packages, hosts, registry images. It's going to show you everything it knows about what's impacted. For the packages, right? These are usually one-click fixes because you can actually submit the pull request, right? So when it's dealing with packages, you can do it that way. For the host, it can't really update them for you, but you do have actions. Create a Jira ticket. You have a Jira integration as well. And so if you create Jira tickets, especially at the top level, it'll create a Jira ticket for all 7 of these hosts assigned to the groups that they're actually assigned to back in on Jira. So it actually can help you with, actioning that for the, for the host that are running. And then registry images, same kind of deal. So registry images, it can't fix immediately, but it can create a Jira ticket for it. Is that what you want to see, Eden? Or
yeah. And then if you go to overview, that is really the most important. But if you go back to that, if you clicked on that log4j, if you go into investigate, right? And this is super cool because what it allows you to do what it allows you to do is one, it allows you to create your own searches and investigate. So much like, how you would query into a MySQL or SPL where you can create conditions and say, what if, create these different queries and policies, specifically, compliance policies that are unique to your organization, or you want to take a policy and augment it to fit your environment, you can do that. But when AJ clicked on environment, essentially what it gave you is a visual depiction of the impacted assets, right? So AJ showed it to you in a tabular format where you can, act upon the different findings and where this propagated across the development lifecycle. But here we can actually look at the resources and we can see how that CVE has impacted our packages and how that's translated to our registry images and which hosts. And then in virtually any view on Prisma Cloud, if you click on any of these icons, you'll be able to get more information, right? So the same thing that AJ showed you where he was able to pull the metadata of that EC2 instance, you'll have that information panel pop up and give you more information around who do you contact? What is the root cause? What is the impact? So it's one of my favorites. So thank you, AJ, for showing that.
And then another thing too, right? Because like as Eden's saying, a lot of these things, especially in the investigate tab, it's a little overwhelming if you've never done this. We have, like Eden said, I think she mentioned RQL. It's research query language. It is kind of, I wouldn't say it's cumbersome, but it is definitely a new thing to learn. One of the things that we're doing to kind of make that a bit better though is if you got this Copilot. Copilot, you could just, plain language. What are my top 5 vulnerabilities, right? It'll churn for a second. And you could just keep discussing with it like, oh, well, it's also in beta, so.
Yeah, it's it works most of the time, and it will give you like a yeah.
But that is also like, that's something that we're trying to add to address this, right? Because like security is one of those things that, especially when you're talking about like security in the cloud, security with development environments, it actually is just, it's hard, right? Let's just face it. Like there's a lot of tools, things are changing constantly. And so we're trying to make it as easy as we can. We're trying to make it easy for developers. People aren't out there like generating insecure code, right? So like we usually give a presentation as well as part of the overview. And it's like, hey, why are we doing this, right? What's the drivers for us? Like, what is it that we're doing? And a lot of the drivers and the things that we're doing is that, the pace of innovation is accelerating because of the cloud, right? Developers are outnumbering security folks. We need developers to help us as security folks to stay secure. And, they need us to help them to do that same thing, right? And so that's exactly what we're doing, Bruce. Like we want to let them know in their language. We want to give them tools in their language. And, and developers are getting tools like Microsoft Copilot exists, right? Or GitHub Copilot exists. And it's going to help you generate code. Well, what we found is that when we go look at code that's been generated by Copilot, 40% of it has some kind of security problem. It's great that you can generate it, but if no one's looking at that code, no one's doing real security testing of the code, you're going to generate a bunch of insecure code and make things even worse. Open source software, great. I love it. In my free time, I'm the world's worst web dev. Hit me up sometime. I'll show you some websites I've terribly done. But the reality is that I build that on the shoulders of giants by including open source packages that other people have done. And if I'm not staying up to date on those packages, I'm going to include packages that have vulnerabilities. Now, the great and wonderful thing about open source software is those people fix those packages. But if I'm not paying attention to it, I'm going to use 7 versions ago that has a giant vulnerability and just not upgrade. And all I got to do is upgrade. And so this is what it's providing. It's providing that visibility, right?
And the
Right.
same way that the developers are going to be leveraging artificial intelligence, so you're going to hear a lot of noise around, hey, artificial intelligence is coming, you need to protect against it. But what you really need to look at is, the security capabilities that you have in-house. How is artificial intelligence enhancing those capabilities? How is it helping your security team scale to meet the demand of developers, which AJ just mentioned, are able to develop much faster with the assistance of Copilot and such, right? And they are developing insecure code and deploying it much faster. And your team is already outnumbered. So it evens out the playing field. Now, AI and ML is, a core component of the platform. And AJ showed you that on the deck, right? The emphasize, how we build machine learning models around your workloads to define anomalies. The data exfiltration or unusual data volume that you saw in the attack path, that was showing from the model that we built around your cloud operations, what's unusual. So we leverage that, but we also want to offer your security practitioners assistance on remediating and getting to the bottom of these security issues much faster. So the AI Copilot is embarrassing us today, but it is in beta, so it's not AJ's fault. So
Don't
yeah,
work, right? I'm not ashamed of it. It
yeah,
happens.
it happens.
So, but I did also want to show you what she was talking, like for compliance is an important part, especially like, so Eden and I both deal with the federal government. Compliance is a huge thing for them, right? So out of the box, you get about 80 or so compliance frameworks. The way those work for us, they're all actually traced back to policies, right? So everything is built off of policies, and we can drill into these and kind of take a look at them. But one of the really cool parts about this, and this is something that's, a real benefit of this tool as well, is like, not only does the policy come out of the box and exist here, right? I can't edit this NIST, 853 Rev 5 here because it's a built-in out of the box policy, right? Can't edit it, I can't delete it. But what I can do is I can clone it. And once I clone it, I can do whatever I want to it. So if NIST 853 has got 85% of what it is that I want and need, then I can start with that as my as my baseline. I can add the 15% that I need, and then I can rename that to whatever, right? AJ Core Security Compliance Framework, and then I can get reports based off of that. And when I go and create a compliance report, so I don't necessarily need it as a as an operator here, right? I could just come in and get live update anytime I want. But when I want to send this to, my CISO or something, he needs it. So I go through and I can find my NIST Rev 5, tell it the account group I want, cloud account, whatever, right? So basically the only thing I really have to select is the cloud type. If I'd like to narrow that down to a particular account group, just a way to, narrow them down to a particular cloud account or even a region of it, right? And then down here, I can email it to wherever I'd like. I can do it as one time or I can do it recurring. And so I could actually set this up to be emailed to the CISO weekly. So he never has to come in here and look at it, but he's going to get a report every week. So that's also nice. I mean, for a lot of folks, it is something that is necessary. And then, like I said, everything that's in that report is just available. So if I come in here and I take a look at all these, right, like I got passed, I got failed, I can go look at the failures that are here directly. And so I don't necessarily need that report as someone who can actually operate the console and look at this, but it's going to break it down and access control. These are all the actual sections of that NIST document. And so I can go in and I can specifically look at, access control. What do I got here? What's passing? What's failing? Right? So, this, like I said, these all come out of the box. All right. But I think, barring any questions or if anything you guys might want to actually see, I think we're about coming up on the end of what we needed to show you. Do you have something, Eden? I'm sorry.
Yeah, no worries. I just wanted to know so that I don't have to make Lewis wait. Lewis asked, large organizations may have multiple Jira instances. Can we integrate more than one instance of Jira? And I'm not sure, so I wanted to know if you had the answer.
I'm actually not sure about that one. We'll have to go back and take a look. I know typically when we go and we do let's take a look. Let's look at our alerts, right?
And to answer your question, Ben, if you're referring to Open Policy Agent at the runtime stage, then we do integrate with it. So the same defenders that AJ was referring to can also act as admission controllers in your containerized environment.
I don't know. Yeah, well, I'll find the answer to that though. I don't know if we could do more than one Jira or not. But yeah, we'll figure that out.
Perfect. So we will get back to you on that, Louis. Great question.
Yeah. Well, actually, I guess we can. Here we go. Integrations.
Yeah,
Jira.
there we go.
There's right there.
Okay.
Yeah, my bad. I guess I just had to figure out I was trying to remember where to integrate Jira in the first place. So
Okay.
that told me.
There we go. So now you know, Louis.
Yeah.
Awesome.
Fantastic.
Any questions? Anything lingering that we didn't get to?
If there are any other questions, like I did mention at the beginning, we will have that location in live community available for people to go ahead and throw questions in the future. After the event here, I'll be getting Eden and AJ both of the links so they can go directly to it themselves, so they can kind of keep an eye on things as well. That's what it's there for. It's a perfect venue for us to continue the conversations there. Anyone has their 2 a.m. refrigerator, open the door and go, oh yeah, I meant to ask them about this. You've got the perfect venue to go ahead and go and share that information and ask away. This has been fantastic with regards to everyone, with the interaction from everyone asking questions. Thank you very much to everyone for that. We really appreciate it. Bruce is saying he'd love to see from the next-gen firewall side the policies and how those integrate to control the WAF functions.
Yeah, that's a great question, Bruce. So like we actually don't, surprisingly enough, right? Like you would think we would. We don't actually integrate with the next-gen firewall with Prisma Cloud. And we have the WAS functions, right? So Web API application security. The thing that makes that kind of cool for us though, right? Like one of the things that we can do here is when we defend and we actually configure these WAS rules, it generally, most applications, API driven applications these days are being written in Swagger Open API. So the tool actually ingest your Swagger Open API specification. It can scan that and give you suggestions about what you should do. And if you start with that as the basis for your rules, so if you look at these policies that I'm looking at here, you actually can import Open API specification, right? And that could be the basis of your rules. And so that's great because we can learn it, right? So we can look at the APIs and we can actually outbound. And over time, what we'll do is we'll learn, what it is that is, interacting with API like links, like with the shape of the data, right? But if you give us the shape of the data, we know exactly what the shape of the data is. And so we can immediately stop, attacks where people are sending bogus data to your API links because we know exactly what it should look like.
Okay, just saw Johnny's comment there about the blog not found for the live link. Somebody on the live team will take a look at that and let you know. Apparently we just lost AJ for some reason. Sorry about that.
Yeah, well, I'm still here.
Appreciate that. Yeah. Anyway, Johnny, in answer to your question, we will go ahead and get this taken care of so that the live link is either going to be working or on the Fuel page for the actual event itself. When we actually post the video and whatnot, we'll post the link for the live event as well in there. And there's AJ back. I'm guessing you meant to stop sharing and hit the wrong button.
No, it for whatever reason told me all my audio and stuff was unavailable and I need to reload the page.
Fascinating. Okay. Well, regardless, I do want to take the quick moment then to thank both of you very much. This has definitely been one of the most interactive and just simply interactive sessions we've had in a while. So I thought this would be going over very well with the Fuel membership, and obviously it has. So thank you very much for both of you for your time. I just have a little bit of a cleanup here at the very end. Let me just go ahead and get this taken care of here. We do have some Spark events coming up at different locations throughout the world, very literally world. As you can see, we have a Sydney event on there, not just US. Please reach out to your local chapters for events if you're interested in going or getting involved more. If you're not sure where your local chapter is, feel free to hit us up. We'll get you connected to the right people. There are 2 more Ignite on Tour events currently scheduled, Sao Paulo on June 26th and Stockholm in September. There might be more coming where we just don't have the dates yet. As we have them, we will go ahead and get them out there for you. We will have a July event. I've just, again, typo on my part here. I apologize. The July event is TBD. We've got a couple of very good topics being figured out right now. We're just trying to get availability from people, and then we'll have that ready for you to get announced hopefully in the next week or so. And then last but not least, we're going to go ahead and be sending out a post-event email. If everyone, as many people as possible, could get back to me on that form and let me know what you liked, what you didn't like. The more input I can get from you, the better these events will be moving forward. So please respond to that survey if you would. I greatly appreciate it. And that is it. Eden, AJ, again, thank you very much. Ladies and gentlemen, thank you very much for attending as well. We really appreciate it. And as I said, I'll keep the chat and the system going here for the next couple of minutes if anyone wants to go back and get any links copied or anything. But thank you very much, everyone.
Thank you all.
And, thank you guys as well. Appreciate you guys having us. And like I said, I can hang out for a couple minutes with you guys, until we decide to shut it down in case someone comes up with a new question.
Yeah, absolutely.
I have a call. So thank you all for having us and have a great day.
Thanks, Eden. Thank you.
Yeah. I'm not nearly as in demand as Eden. So
I hear you on that one. Absolutely. Yes. Yeah. If there's any other questions anyone has, still gonna stick around for a little bit. So feel free to ask. AJ, I was actually curious about one very minor thing. When you were talking about the different integrations on one of your first slides, you mentioned Slack and whatnot. Have you guys noticed any kind of an uptick with regards to people wanting to use Discord in more of a corporate use, or not really?
I haven't heard anybody for my customers, right? Because I don't generally deal with a lot of corporate customers. The one that we see more than anything was like we had, I think, Slack first, and then we started having, Microsoft Teams. The federal government's really in the Microsoft, right? Which we definitely added that one. The one thing I will say though, and I don't know if this will benefit Discord or not, and that's why I wanted to show the integration slide for a second, was that we do actually, like when I pulled up the integration or whatnot, or not slide, I'm sorry, when I pulled up the integration, like here's the pop out, there was in there a webhook, right? So webhook is very generic. Most things, like they'll accept a webhook. Yep. So if we don't have like a out of the box built integration, but your app will accept a webhook, then you can integrate it.
Gotcha. Fantastic.
And so that's usually what I tell people when they're like, oh, I got this, whatever application. And I was like, well, does it, if it accepts a webhook, right? And in some cases, what customers will do is they might write like basically custom middleware where they'll develop an application that does accept a webhook that then uses the APIs for the application they want to integrate to and then translate, right? So they basically just set between. And so the integration is, send the message to the new container that's accepting that webhook. And then that container translates the message from, because it's usually just coming in as JSON, right? And it's just going to translate it from that JSON into whatever format and API format they need for whatever weird system that we don't have a custom built integration for. And then, but like anything, if you have a need for it and you're going, we get enough customers say, hey, but we really need to connect to, Discord, then, probably build a custom integration for it at some point. But no, I just haven't seen, in my neck of the woods, right? I haven't seen a lot of Discord. I do see Discord though, because again, like I said, put back on my hobbyist hat as the world's worst web dev. A lot of those communities are in Discord, and even to the point of like even communities like this, they're sort of moving. So Slack used to be where a lot of have their chat, but they're starting to move to Discord as well.
Yeah, and that's what I've been noticing too. Is I'm noticing a lot. Discord is not just for gaming anymore. Yeah, it was that way for the longest time because the easy integrations with all the different systems out there. But nowadays, there's so many other things that just Discord is being used for. I'm a member on a Discord server for multiple different topics. So just, again, figured the question would be there. So.
No, it's a great question. Like I said, but that's generally how I handle it. Like, I said, I get that question sometimes too, but like usually because we do have the webhook, if you can't integrate it because we don't have like the, simple click and, fill out these six fields and we'll do the integration for you. The webhook is available and will work for most other use cases.
Gotcha. Cool.
Yep.
Well, it looks like we're not getting any more questions, so we'll go ahead and wrap things up then. Again, thanks, AJ. Really appreciate it. And thank you, everyone who's attending. We'll go ahead and shut things down now and hope everybody has a great rest of your day. Thank you very much for coming, everyone.
Yeah.
Bye-bye.
Bye-bye.